at a constant volume. So the decomposition is of SO2Cl2, that's just high-only fluoride is happening at a constant volume. They have also provided you with the reaction SO2Cl2 का thermal decomposition will give SO2 plus Cl2. It is the gaseous reaction. Now they have also given you a data, which is experimental data with the time and the total pressure at the two different times. And you need to calculate the rate of the reaction when the total pressure. Okay, take it. So let me first write down the tabular data. So this is the experiment. This is the time in seconds. This is total pressure, and they have used ATM. Okay, so they have performed basically two experiments. For time 0, the total pressure was 0.5, and for time 100 seconds, the pressure became 0.6. Now you can say when this tabular data is in the form of the concentration, is in terms of concentration, then the initial concentration decreases with time because the reactants are getting utilized. But here, if you observe the total pressure column, you will see that with increasing time, the total pressure is also increasing. How is that possible? Because this column, it does not tell us the pressure of the reactant species, the pressure exerted by the reactant species. It is the total pressure, as the name suggests. So total pressure is the pressure which is exerted by the complete system. If there are three species in this reaction, SO2Cl2 and SO2 and Cl2, there are three species. So the total pressure is the pressure is the sum of the partial pressures of all the three species at that particular time. That is at 100 seconds. जब सबका partial pressure add करने के बाद we would get 0.6. ठीक है, तो ये this difference you should be aware of, that why the total pressure is increasing with time. Okay, so now and one thing more, we need to calculate the rate of the reaction. When total pressure is 0.65 atm. Matlab they have not asked for the rate of the reaction at this data point. Matlab they have given the data at 100 seconds. So उन्हें उस time का rate नहीं चाहिए. उन्हें चाहिए when the total pressure is 0.65 atm. Okay, so this is the question. Let's solve this. So we have also discussed this type of a question, this kind of a question, while we were doing some in-text questions, like in between questions that we do when the chapter was going on. So there also I told you that the purely gaseous reactions in which all the reactants and the products, they are gaseous in phase. They are the data you can get in terms of total pressure also, and there how will you proceed? Okay, so the first step of this kind of a question will be to write down the pressures of the species. ठीक है, तो इसको जैसे हम क्या करेंगे, we will start with writing the reaction. SO2Cl2 will give SO2 plus Cl2. ठीक है, तो क्या होता है, at T is 0. Initially जो हमारा initial pressure है, that is T naught. Initial हमेशा हम लोग नॉट से डिनोट करते हैं, this is T naught. And because at time T equals to 0, we do not have any SO2 and Cl2, which are the products, so we will take 0. ठीक है, now at some time T, ठीक है, we will say कि at some time t, the pressure of SO2Cl2 will decrease, obviously, because it is getting utilized, तो उसका concentration भी कम होगा if we talk in terms of concentration. But in terms of pressure, its individual pressure, its partial pressure will also decrease. ठीक है, तो because we as in terms of concentration हम x लेते हैं कि we just assume कि the concentration has been decreased by x. So similarly, यहाँ पे we will take small p. So suppose the partial pressure of SO2Cl2 has been decreased by small p. ठीक है, so finally at time t this would be P naught minus P. ठीक है, P partial pressure या P ATM pressure कम हो गया SO2Cl2 का. So because they are also 1 moles, the products are also 1 mole quantity. So that is why when SO2Cl2 is getting reduced by P, so the products will also get increased by P. Okay, because because you have to take the ratio of the stoichiometric coefficients. We have already discussed this. Okay, so because SO2Cl2 is decreasing by P, that is why SO2 and Cl2 both will increase by P. So these are the partial pressures of the different species at a particular time t. Now at this time t, so if we go for total pressure, okay, these are the partial pressures. If we go for the total pressure, what you need to do? You need to simply add all these and you will get P naught plus small p. Okay, we denote this total pressure by PT suppose. ठीक है, तो अब हमें दिस पीटी इज नोन. द पॉइंट इज जो हमें टेबल में दिया है वो ये चीज है, पीटी टोटल प्रेशर एट सम टाइम टी. ठीक है, बिकॉज पीटी इज ऑल्सो नोन एंड पी नॉट इज ऑल्सो नोन बट स्मॉल पी इज नॉट नोन. ठीक है, तो व्हाट वी विल डू इज small p is unknown, so we will write it in terms of pt minus p naught will be small p. ठीक है, now चलो because it was unknown, so we have found out the value of small p in terms of pt and p naught, which were the known values. ये तो हमने लिख दिया. अब what we need to do is अच्छा in the question, okay, in the question they have also mentioned, I think I forgot to mention that the reaction is first order reaction. ठीक है, तो n is equals to 1 they have mentioned in the question. ठीक है, so because they have already mentioned the n, the order of the reaction, so we can directly use the integrated rate law for the first order reaction. Okay, it becomes k, so 0.303 by t log of initial pressure which is P naught divided by final pressure. ठीक है, अब यहाँ पे जो फाइनल प्रेशर आता है एट टाइम t, वो क्या होना चाहिए? जैसे हम लोग कंसंट्रेशन के लिए ये इक्वेशन लिखते हैं तो उसके अंदर वी राइट इट लाइक दिस, log of a naught divided by a. ठीक है, तो हम what we are basically this is the ratio of the initial concentration of the reactant to the final concentration of the same reactant. ठीक है, यहाँ पे हम टोटल कुछ नहीं ले रहे, यहाँ पे हमें लिखना है उसी रिएक्टेंट का फाइनल कंसंट्रेशन. सिमिलरली हियर आल्सो वी विल राइट द पार्शियल प्रेशर ऑफ दैट रिएक्टेंट एट टाइम t. ठीक है, वी आई मीन पीपल स्टूडेंट्स माइट गेट कंफ्यूज कि यहाँ पे pt आएगा बिकॉज इट इज गिवन इन द टेबल बट दिस इज नॉट द वे. यहाँ पे इट विल कम द पार्शियल प्रेशर ऑफ द रिएक्टेंट एट टाइम t इन द डिनोमिनेटर. ठीक है, तो इफ वी गो बैक हम क्या देख रहे हैं कि एट टाइम t, दिस टाइम t, द पार्शियल प्रेशर ऑफ SO2Cl2 इज P नॉट माइनस P. ठीक है, तो यहाँ पे हमारा जो पार्शियल प्रेशर है वो क्या है? P नॉट माइनस P. ठीक है, सो इफ तो टाइम t पे पार्शियल प्रेशर इज P नॉट माइनस स्मॉल p. ठीक है, बट नाउ क्योंकि हमें स्मॉल p की वैल्यू तो पता नहीं है, तो हमने पीछे क्या किया है, यहाँ पे स्मॉल p की वैल्यू निकाली है, दैट इज pt माइनस p नॉट. ठीक है, सो वी विल सिंपली पुट दिस वैल्यू ओवर हियर, दिस इज p नॉट माइनस pt माइनस p नॉट. ठीक है, तो यहाँ पे क्या आएगा, इट विल बी p नॉट माइनस pt प्लस p नॉट, फाइनली 2p नॉट minus pt. 2p naught minus pt. So this is what I mean. This is ये कुछ नहीं है. This is simply the partial pressure of SO2Cl2 at time t, but in terms of the known values. ठीक है, मतलब आप अगर मैं इसको ऐसे लिखूं तो this would be p naught minus small p. अगर हम वो टेबल देखें तो वो जो अभी हमने पीछे खुद बनाई है यहाँ पे, तो एट टाइम टी दिस इज p नॉट माइनस p, राइट. तो अगर हम उसे फिट करें तो दिस विल बी दिस, बट इफ बिकॉज वी डू नॉट नो द वैल्यू ऑफ स्मॉल p, so that is why we just write it in terms of the known values which is pt and p naught. ठीक है, तो अब हम in terms of known values what we can write is p naught divided by 2p naught minus pt. This is in terms of the values which are given in the table. ठीक है, तो क्योंकि हमें बिकॉज वी डू नॉट देखिए उन्होंने दे हैव आस्क्ड फॉर द रेट ऑफ द रिएक्शन एट when a total pressure is 0.65, but they have not given the time for the total that at that time. ठीक है, हमें टाइम नहीं पता, सो फर्स्ट वी नीड टू फाइंड आउट द वैल्यू ऑफ के ओवर हियर. ठीक है, तो हम सिंपली एट टाइम 100 सेकेंड्स जब हम लोग के की वैल्यू निकालेंगे, दिस वुड बी ना divided by 100 in seconds log p naught was 0.5 initial pressure from the table, and it would be 2 into 0.5 minus pt is 0.6 from the table. ठीक है, so this will be 1 minus 0.6 और this will be 0.4, तो log के अंदर 5/4 आएगा. ठीक है, तो 2.303 by 100 log 5/4. On calculation you will find k will be 2.231 into 10 to the power minus 3 per second. Per second because first of all the unit of the rate constant for the first order reaction is time inverse, और क्योंकि यहाँ पे seconds में time दिया है, so that is why this is per second. 2.231 into 10 to the power minus 3. Now they have asked the rate of the reaction when total pressure is 0.65 और उन्होंने time नहीं दिया है. So because the reaction is same, the temperature is also same, so k का value उस time पे भी same ही रहेगा. ठीक है, because the temperature and all is not changing. So now you can call it as this as the other part of the question. You have already found the value of k. Now you know what you do. Now for pt, when the total pressure is 0.65 atm, when we do the calculation for this, because see, we cannot apply the integrated rate law over here. Why? Because we do not know the value of time. Matlab, even if we put the value of pt in the integrated rate law, we have now known the value of k, but we do not know the value of time. So how will we calculate? ठीक है, so that is why rate निकालने के लिए what we will do is हम इसको मतलब we'll solve it in the opposite, in the reverse direction. They have given you the value of pt ठीक है, एंड यू नो दैट PT इज इक्वल्स टू P नॉट प्लस स्मॉल p। ठीक है, P नॉट आपको पता है कितने, 0.5 विच इज द इनिशियल प्रेशर, एंड PT is 0.65. So according to this convention, जो हमारा small p होगा, that will be PT minus P naught, which is 0.65 minus 0.5, which is 0.15. ठीक है, this is what? This is small p value. ATM. Obviously, I mean everything is ATM. These are all pressures. So this is small p, which is 0.15 ATM according to our convention. ठीक है, तो the partial pressure of SO2Cl2 is P naught minus P at some particular time T. ठीक है, तो इस केस में जब हमारा टोटल प्रेशर 0.65 है, तो जो हमारा पार्शियल प्रेशर है ऑफ SO2, जिसको हम लोग ऐसे भी लिख सकते हैं, पार्शियल प्रेशर ऑफ आर रिएक्टेंट SO2Cl2 क्या है, दैट इज P naught minus P. P naught minus P at this time. P naught is again 0.5, but P is 0.15 here. So this will be 0.35 ATM. ठीक है, ये सारी जो वैल्यूज हैं, पार्शियल प्रेशर ऑफ SO2Cl2 और स्मॉल p और PT, ये सारी वैल्यूज है व्हेन PT इज 0.65 ATM. ठीक है, तो ये सारी और ऊपर जो हमने K का वैल्यू यूज करने के लिए सारा डेटा यूज किया है, दैट इज व्हेन टाइम इज 100 सेकेंड्स. दिस इज फॉर टाइम विच इज मोर देन 100 सेकेंड्स. ठीक है, so this is 0.35 ATM, which is the partial pressure of SO2Cl2. Now, if you write the rate law, the rate equation, sorry, rate will be K times of, जैसे हम concentration of the reactant लिखते हैं, वैसे ही in terms of pressure we will write the pressure or the partial pressure of the reactant. ठीक है, total pressure यहाँ पे भी नहीं आएगा, जैसे integrated rate law में we were using the partial pressure of the reactant. Similarly, in the rate law, the normal rate law also, you will use the partial pressure of the reactant. So this will be K into the partial pressure. Now you understand why we have calculated all this, right? Why we have calculated the value of small p at that time. So rate will now be equal to, you already have the value of K from the first part of the question multiplied by the partial pressure of SO2 for this time is 0.35 ATM. Okay, this is ATM. So now, on multiplying it, you will get the value around 7.8 to 10 to the power minus 4. And the unit would be, because this is ATM, per second. Okay, 7.8 into 10 to the power minus 4 atmospheres per second. This is the rate of the reaction when the total pressure was measured to be 0.65 ATM. Okay, so see, they have not directly, they have not directly given the value of K. So there is a technique through which they have asked you to calculate the value of A, to determine the value of A. और फिर उसके बाद उन्होंने सेकंड पार्ट ऑफ द क्वेश्चन में एक्चुअली में दे वांटेड टू यू टू फाइंड द रेट. ठीक है, सो दो पार्ट में क्वेश्चन को आपको करना है. ओके, so now we'll move on to next question. The question says, consider a certain reaction which is A to products with K. Okay, so they have given you the value of K. So K for this reaction is how much? 2.2 into 10 to the power minus 2 per second. Okay, now calculate the concentration of A which is remaining after 100 seconds if the initial concentration of A is 1 mole per liter. Okay, so what are they asking? I'm again repeating the question. Calculate the concentration of A which is remaining after 100 seconds if the initial concentration of A is 1 mole per liter. So they have also given you the initial concentration of A, which is 1 mole per liter, and they have asked the concentration of A remaining, which is the final concentration of A after 100 seconds. So basically, they are wanting to find the concentration at time 100 seconds. Okay. So the reaction seems, the question is very easy. I mean, they have given the initial concentration also, they have given time also, they have given K also, and you need to find a value of A at this time. Okay. But you will observe in the question that they have not provided. I have repeated the question. Also, they have not provided the order of the reaction. इन्होंने नहीं दिया यहाँ पे. ठीक है, जैसे in the other questions they simply explicitly mention okay for a first order reaction or for a zero order reaction or for a second order reaction, whatever. But in this question they have not mentioned the order. So what you need to do in such cases, okay, you don't have to get confused. You simply have to look at the unit of this rate constant. ठीक है, ये मैंने उस टाइम पे भी बात बताया था when you were doing the units of rate constant कि the only purpose is for those questions, for those tricky questions जिसमें कि they do not provide you the value, the order of the reaction explicitly. You could be able to find the order of the reaction from the question itself. ठीक है, तो आपको कुछ करना नहीं है, you simply आप K का जो यूनिट है वो देखो which is per second and you know कि जो टाइम इनवर्स होता है this is the unit of the rate constant for the first order reaction. ठीक है, और जीरो ऑर्डर रिएक्शन का अलग होता है, दैट्स डिफरेंट. तो अगर वो है यूनिट तो आपको पता चल जाएगा कि दैट इज दिस इज के इज फॉर द जीरो ऑर्डर रिएक्शन, बट हियर इट इज फॉर द फर्स्ट ऑर्डर रिएक्शन. ठीक है, तो आपको सिंपली फ्रॉम द क्वेश्चन, सो from the unit of K, we get that the reaction is first order. Okay, n is equals to 1. As I'm writing it because I want you to remember it and be aware of this condition. That in some tricky questions you can do this. Okay. So from the unit of K, the value of n is 1. That is, it is a first order reaction. Now the question is normal. आप simply first order के लिए, when you will know the order of the reaction, only then you can apply the integrated rate law. Okay. Otherwise, zero order के लिए you have a different integrated rate law. So for the first order, we will write down the integrated rate law, which says K is 2.303 by T log of initial concentration upon final concentration. ठीक है, so this is the integrated rate law. Now अब इसमें आपको what is known, K is known, T is known, initial concentration is also known, and you need to find the final concentration. So everything else is known. So we will simply put the values. Two into 10 to the power minus 2, 2.302, time is 100 seconds, be it in seconds. Log initial is 1, final is this. ठीक है, तो आपको पता है 1 upon a को we can write it in terms of minus a. ठीक है, when when 1 upon a, basically I want to say कि ये जो log है 1 upon this, we can write it in terms of minus. So see what is happening, this is log a to the power minus 1. ठीक है, when something is in the denominator and you want to take it to the numerator, so up minus 1, you can take it to minus 1 power. ठीक है, now with the help of property of log, this minus 1 can come in front, outside of the log, and you can write it in this way. So this is basically minus 1 log a or minus log a. ठीक है, so if you write it here also, so this will look like माइनस विल कम ओवर हियर, आगे log a, ठीक है। अब आपको यू नीड टू फाइंड दिस a, दैट्स इट, ठीक है। व्हेन दिस 100 विल गो एंड मल्टीप्लाई देयर on the other side, standard power -2 will get cancelled. Okay, so this is basically 2 over here, and okay. So next will be log of a. Upon arranging several things here and there, you will get that log of a will be -2 divided by 2.303, क्योंकि 10 to the power -2 and 100 is getting cancelled. ठीक है। So when you will solve this, तो आपको क्या करना पड़ेगा, एंटी लॉग लेना पड़ेगा इस पूरी चीज का। यू विल टेक द एंटी लॉग ऑफ द आरएचएस। तो क्या होगा, ये जो फाइनल ए का कॉन्सेंट्रेशन होगा ना, दैट विल बी इक्वल टू एंटी लॉग, यू विल यूज द कैलकुलेटर, माइनस 2 by 2.303. So you will get the answer as 0.135, and for units you will take mole per liter. So this is the answer. The final concentration at 100 seconds, 0.135 mole per liter. Next question. The question seems, I'll read it out, that the sucrose decomposes in an acid solution into glucose and fructose. So basically the reaction is sucrose decomposing to, I will write it, sucrose decomposes in an acid solution to glucose and fructose. According to the first order rate law, ठीक है। तो इन्होंने ये भी मेंशन कर दिया है कि the reaction is first order rate law with half life. They have also given you the half life as is 3 hours. Okay, the reaction is quite slow with half life as 3 hours. Now the what you need to find out is what fraction of a sample of sucrose remains after 8 hours. ठीक है। तो पहली बात, एज आई टोल्ड यू, ऐसा नहीं है कि इफ आधा खत्म होने के लिए 3 घंटा लग रहा है तो पूरा खत्म होने के लिए 6 घंटा लगेगा, ठीक है। तो यू शुड ऑलवेज अंडरस्टैंड कि दिस इज वेरी रॉन्ग फॉर एनी ऑर्डर रिएक्शन, ठीक है, चाहे 0 हो, फर्स्ट हो, सेकंड हो। दिस थिंग इज वेरी रॉन्ग कि इफ द हाफ लाइफ इज 3 hours, so it will take 6 hours for the completion of the reaction. It never happens. The reaction fully complete कभी होता ही नहीं है in truly. So rather you need to do it with the help of rate laws. What fraction of a sample of sucrose remains after 8 hours? Second, so what you need to do is, they have given everything. First, you will write down the integrated rate law for n is equals to 1. So it says K is 2.303 by time log of A naught by A. So see, the reaction is first order reaction and they have provided you with the half life. Okay, so what is the need of half life is they have indirectly wanted to find out the value of K. Q. Because for the first order reaction, K is inversely proportional to the half life. Okay, so if half life is 3 hours, so K will be simply 0.693 by half life, which is 0.693 by 3 जब आप करोगे in hours, you will get 0.231 hour inverse. Okay, this is the value of K. Now they have given you the, okay, so they have not given us the initial concentration and the final concentration of of sucrose. They want us to find a fraction of the sample of sucrose which remains after 8 hours. So basically, उन्हें fraction चाहिए, उन्हें एक relative value चाहिए, उन्हें I mean they do not want the absolute concentration of A. ठीक है, क्योंकि because they have not provided the initial data. तो आपको कुछ नहीं करना, आप simply you just put the values and find out the value of this fraction which is inside log. ठीक है, तो K को first of all K will be 0.231 hour inverse 2.303 divided by time is 8 hours, 8h log of A naught by A. So when you will calculate this, so you will get A naught by A will be anti-log, because it is inside log. So if the unknown value is inside log, then आपको कहीं ना कहीं पे anti-log perform करना पड़ेगा. ठीक है, आप उसको पहले properly you get like this is log, this is some x value, and यहाँ पे कुछ आपका known बताए constant है. ठीक है, when you do the calculation, this will be a constant because it is known. ठीक है, तो आप जब anti-log लोगे both the sides, so this will cancel out and this will become anti-log of this constant. ठीक है, so this is how it works. Similarly, आप यहाँ पे जब anti-log लोगे, so this would be on calculation, this would be 0.8024, and the numerical value will be anti-log 6.345, the approximate value 3.645. So this is the fraction. Okay, what they have asked? They have simply asked the fraction of sample of sucrose which is remaining after 8 hours. Okay, so they are basically asking for this. Okay, yes, they are basically asking for the inverse, the reciprocal of this ratio. Okay, so actual में answer होगा ना, that would be A divided by A naught. Because तभी आप उसको उस fraction में लिख सकते हो. So when you will do the reciprocal of this quantity, you would get 1576. ठीक है, तो आप स्टेटमेंट से क्या लिख सकते हो कि जो हमारा फाइनल कंसंट्रेशन है दैट इज 0.1576 ऑफ द इनिशियल कंसंट्रेशन. ठीक है, तो यही आपका एक्चुअल में आंसर है. दिस इज द फ्रैक्शन दे वर आस्किंग अबाउट of sucrose which is remaining after 8 hours. So this is the answer. Okay. Or similarly, they can also, frame a question in terms of percentage. Okay. Like they have asked for the fraction of sample, they could also ask fraction, the percentage. Then आप क्या करते हो? As I told you, कि if they ask in terms of percentage, the best technique is to assume the initial concentration to be 100 and find out the final concentration. ठीक है, तो अगर मान लो इनिशियल कंसंट्रेशन आपने ए नॉट की जगह यू हैव पुट 100 and final concentration you are finding out the exact value and you get it to be around 80. ठीक है, तो आप क्या बोल सकते हो कि final concentration is 80, so that means 80 and 20% has been utilized. ठीक है, so इसका मतलब 80% of the reaction is still left, it is remaining. So the answer would be 80% in that case. कि कितना सुक्रोज बच रहा है, that is 80% of the sucrose is still left in that case. So just remember कि for the case of percentage, it's good to assume the initial concentration to be 100 and then find out the final concentration. But for the case of fraction, you can directly, you can directly put the values and find out these in terms of the fraction. So this answer in terms of fraction will always be less than 1. ठीक है, आप अगर अगर आप ये वाला लेते हो 6.345, so it will not be an answer because you know कि the reactant जो है that is decreasing, that's being utilized. So that is why this answer should always be less than 1 and the percentage should always be less than 100. ठीक है. Now next question. So the next question is says the rate constant for the first order decomposition of H2O2, which is hydrogen peroxide, is given by the following equation. So what they have given कि एक कोई reaction है which is the decomposition of H2O2. It is given by the following equation. So first of all, they have given the order. Then they have given an expression which is log K 14.34 minus 125 into 10 to the power 4 K by T. ठीक है, तो ये सिंपली एक एक्सप्रेशन है which is provided in the question, given in the question. You need to calculate the activation energy for this reaction. First part says that you need to calculate the activation energy and at what temperature will its half period or half life be 256 minutes. And second part says, I write this down, at what temperature will its half life be 256 minutes. Okay, so agar, you know, if you see this last statement, last question, the second part, so that is they are asking the temperature at which the half life is 256 minutes. That means even the half life is depending upon temperature, and you know the reason why it's depending, because for the first order reaction, half life is inversely proportional to the rate constant. Okay, and when the rate constant is changing with temperature, according to this relation that they have given, so the rate constant changes with temperature, and because of that, half life will also change with temperature. ठीक है, तो अगर आप देखो इस इक्वेशन में if you put the value of temperature, you will get the value of K, or vice versa. If you put the value of K, you will get the value of temperature from this equation. ठीक है, तो first of all हम क्या करेंगे, we will proceed to find out the activation energy. ठीक है, अब आपको पता है, okay, we will first, you know that the actually how is our the rate constant and the temperature related using the Arrhenius equation. That's the main equation for the dependence of the rate constant on temperature. So we will start by writing down the Arrhenius equation. Arrhenius equation says that K is A into e to the power minus activation energy by RT. Simple. ठीक है, so because K जो हो है होगा, it will be related with temperature like that, like with this relation. अब आप देखो ऊपर इक्वेशन में what they have written, they have simply written log K, they have not taken K, it is log K. तो हम क्या करेंगे, we will also take logarithm on both the sides of this Arrhenius equation, taking log on both the sides. ठीक है, वाई हमारे लिए जरूरत नहीं है, बट बिकॉज इन द क्वेश्चन द इक्वेशन दैट दे हैव प्रोवाइडेड दैट इज इन लॉग ऑफ के, सो दैट इज वाई उसको बराबर करने के लिए वी विल आल्सो पुट लॉग. सो यू नो व्हेन यू विल टेक लॉग, इट विल बिकम log k will be log a plus log of this. So log a. Okay, so because this is e, so we should have taken ln. So this would be ln k will be equal to ln a minus ea by rt. Now when you convert it into log, आप क्या करोगे, यू सिंपली मल्टीप्लाई इट बाय 2.303। हर जगह पे जब इधर से डिवाइड करोगे तो ओके, सो यू विल गेट log k विच इज log a माइनस ई ए बाय आर टी, और आर टी के साथ में यू विल गेट यहाँ पे 2.303 बिकॉज ऑफ एल एन। ठीक है, मतलब मैंने क्या किया है, आप पहले एल एन लीजिए, so it will be ln k, ln is natural log, so to the base e, so ln k will be ln a minus ea by rt. ठीक है, and as you know that when you are removing ln you need to put 2.303. ठीक है, तो everywhere you will get 2.303 यहाँ पे in, so the equation would be 2.303 log of k, which will be equal to 2.303 log of a minus ea by rt. ठीक है, आपने ln को log में कन्वर्ट करोगे तो ऐसा लगेगा सिंपली। तो आपको क्या करना है, ln की जगह पे आप रिप्लेस कर दो 2.303 log। ठीक है, फिर व्हेन यू विल डिवाइड द होल इक्वेशन बाय 2.303, so this will be I mean converted to this form what I have already written. Okay, तो I'll erase this thing. ठीक है, सो दिस इज द इक्वेशन इन टर्म्स ऑफ लॉग जो कि हमें यहाँ से मिल गई है। ठीक है, now they have given out this equation, so log k is some expression, similarly here also log k is some expression, so you simply have to compare these both two equations. So on comparison आपको values पता चल जाएंगे on comparison log k है on the side of LHS with both these equations they have log k, then you have log a minus, so you can clearly see कि यहाँ पे जो 14.34 है that is log a. So on comparison you will find out that log a is 14.34. बट क्योंकि हमें एक्टिवेशन एनर्जी चाहिए रिएक्शन के लिए, so what we will do is we will compare the other part. ठीक है, so that would be EA by RT and 2.303 there. This is from the above equation. This is 1.25 into 10 to the power 4. This K is nothing. This is Kelvin. Okay, so they wanted. I mean, this K is always Kelvin. Divided by temperature. ठीक है, अब आपको क्या करना है, आपको दिख रहा है कि दोनों तरफ दिस इज आई मीन बोथ द इक्वेशंस दे आर डिवाइडेड बाय टेम्परेचर डिवाइडेड बाय टी। ठीक है, सो आई मीन टी इज कॉमन ओवर हियर, तो आप इस चीज से ऐसा भी लिख सकते हो कि यहाँ पे द यूनिट्स आर इन SI यूनिट्स। ठीक है, सो I mean we'll go to the next page. So this will be activation energy from this last expression. This will simply be जो 1.25 का फैक्टर है into 10 to the power 4 into 2.303 into R, and R will be according to our SI unit convention. This is 8.314 joules per Kelvin per mole. ठीक है, तो यहाँ पे ऑल्सो दे हैव गिवन केल्विन, नो, ऊपर भी उन्होंने केल्विन दिया हुआ था, सो दिस इज जस्ट टू कैंसिल दैट केल्विन, बिकॉज एक्टिवेशन एनर्जी है वो एनर्जी है, सो दिस विल हैव द यूनिट्स ऑफ एनर्जी विच इज जूल पर मोल. So finally the value of activation energy would be, according to the calculation, this would be this is a big number, 239,339.3 joule per mole. So this is the activation energy of the reaction which we have calculated. यहाँ पे हमने कुछ कैलकुलेट नहीं किया है, वी हैव सिंपली कंपेयर्ड बोथ दीज इक्वेशंस. बस हमें आर्हीनियस इक्वेशन को उस फॉर्म में लिखना है जिस फॉर्म में क्वेश्चन में गिवन है, एंड यू कैन कंपेयर इट. ठीक है, इफ इट इज गिवन इन द फॉर्म ऑफ अ लाइन, दैट इज अ स्ट्रेट लाइन, तो आप उसको स्ट्रेट लाइन की उससे कंपेयर करो. इफ इट इज गिवन इन टर्म्स ऑफ लॉग, तो आप उसको लॉग की कंपेयर करो. इफ इट इज गिवन इन टर्म्स ऑफ एल एन, यू ऑल्सो राइट आर्हीनियस इक्वेशन इन टर्म्स ऑफ एल एन. ठीक है, तो फॉर्मुलेशन कन्वेंशन सेम होना चाहिए. नाउ द क्वेश्चन सेज कि द क्वेश्चन सेज कि एट व्हाट टेम्परेचर द हाफ लाइफ विल बी 256 मिनट्स. ठीक है, तो हाफ लाइफ इज गिवन, तो बेसिकली व्हाट आर दे ट्राइंग टू से कि पर्टिकुलर टेम्परेचर पे हाफ लाइफ इतना है. इसका मतलब पर्टिकुलर टेम्परेचर पे फ्रॉम दिस हाफ लाइफ वैल्यू वी कैन कैलकुलेट द वैल्यू ऑफ के एट दैट टेम्परेचर. So when, now this is the second part. Here comes the second part. So they have given the half life as 256 minutes. ठीक है, तो फर्स्ट थिंग हम क्या करेंगे, हाफ लाइफ को कन्वर्ट करेंगे के में, विच इज 0.693 by half life is 256 minutes. So because, so the best way is to take it in minute, or I mean you can also take it in second, because हमने जो एनर्जी लिया है, जो हमारा एक्टिवेशन एनर्जी है, दैट इज इन जूल पर मोल. दैट इज अ SI सिस्टम, एंड SI सिस्टम में द यूनिट शुड बी इन सेकेंड्स. ठीक है, मिनट्स नहीं चलेगा. I mean, in that equation, in the Arrhenius equation, you cannot you have to take all the units to be uniform. ना, the system uniform होना चाहिए units का. ठीक है, so because activation energy is in terms of joule per mole, so that is why जो हमारा half life होगा उसको हमको seconds में convert करना पड़ेगा. Some seconds multiplied by 60 and you'll get the value in seconds. ठीक है, so the final value of K, I'm writing down the value. 4.51 into 10 to the power minus 5 per second. ठीक है, so this is the value of K in per second. तो हमारे यूनिट सिस्टम के हिसाब से है, SI के हिसाब से. Now you have got the value of K using the half life at that particular temperature. ठीक है, जिसमें हाफ लाइफ इतना था, तो उस टेम्परेचर पे K का जो वैल्यू है वो ये है. Now what you will do, they have given that equation. उस equation में आप simply you just put the value of this K and find out the value of temperature. उनकी खुद की equation से. ठीक है, तो their equation was log of K, बिकॉज यहाँ पे वो क्या बोल रहे हैं, सिस्टम जो है वो उनकी दी हुई इक्वेशन है. द इक्वेशन व्हिच इज गिवन इन द क्वेश्चन, द सिस्टम इज फॉलोइंग दैट पर्टिकुलर इक्वेशन, so we will use that equation itself. And obviously the numbers are also calculated, so you don't need to do much calculation here. Into 10 to the power 4 Kelvin by temperature. ठीक है, ये है equation. You simply put log of this value and find out the value of temperature over here. K is just Kelvin. K is not a constant. So on doing the calculation, you will find out that temperature is coming out around 669 Kelvin approximately. I mean, it is in terms of 668.9 something. So the approximately value on rounding off, it would be temperature would be 669 Kelvin. So at this temperature, the value of K is the above value, and the value of half life is 256 minutes. ठीक है, Now coming to the next question. And this was question number 4. Now we number 5. So here the question says, just listen to it carefully, that the time required for the 10% completion of a first order reaction at 298 Kelvin is equal to that which is required for its 25% completion at 308 Kelvin. Okay. So if the value of A is, okay, this is the value of that constant, calculate K at this temperature and the activation energy. Okay, so this is a tricky question. I will write it down. First of all, they are telling कि जो reaction है, they have not given the reaction because it's not needed. उन्होंने बस order बताया है कि it is first order reaction. So they are saying that the time which is required for 10% completion. 10% completion, and this is at some temperature which is 298 Kelvin. The temperature is very important क्योंकि हमें पता है कि the rate constant changes with temperature. At 298 Kelvin is equal to the time which is required for 25% completion at some other temperature which is 308 Kelvin. ठीक है, तो बेसिकली हो क्या रहा है कि दे आर डूइंग द सेम रिएक्शन एट द डिफरेंट टेम्परेचर और वहां पे वो कंपेयर कर रहे हैं रिजल्ट्स को. ठीक है, तो जब व्हेन दे आर डूइंग इट फॉर 298 केल्विन एंड दे आर डूइंग द सेम रिएक्शन फॉर 308 केल्विन. ठीक है, एंड देन दे आर कंपेयरिंग द टाइम. सो दिस इज द डेटा दैट दे हैव गिवन इन द क्वेश्चन. They have also given the value of A, which is the Arrhenius factor, because it would be needed lately. 4 into, oh, this is very high, 4 into 10 to the power 10 per second. Okay. So the value of A also depends upon the order of the reaction. ठीक है, क्योंकि ये फर्स्ट ऑर्डर रिएक्शन है, so it will have the value जो A का यूनिट होगा that will be same as a unit of K. So that is why this is per second. 4 into 10 to the power 10 per second. You need to find K at, okay, so this is some third temperature, 318 Kelvin, even higher, and the activation energy. Okay, so this will be this is a good question actually. Seems tricky. So first of all, because they have given the order of the reaction, तो हमें सबसे पहले क्या करना है? For a first order reaction, write down the integrated rate law. ठीक है, तो एज आई टोल्ड यू कि जब भी कंप्लीशन दिया है, अभी भी हमने इसके पहले प्रीवियस क्वेश्चन में भी डिस्कस किया था कि इफ दे हैव गिवन इन टर्म्स ऑफ द परसेंटेज. ठीक है, तो हमें क्या अज्यूम करना है? जस्ट अज्यूम द इनिशियल कंसंट्रेशन टू बी 100 एंड द फाइनल कंसंट्रेशन जस्ट अकॉर्डिंग टू दैट, जो भी न्यूमेरिक्स है. ठीक है, तो क्या हो जाएगा? फॉर द फर्स्ट ऑर्डर रिएक्शन यू विल राइट T, which is 2.303 by K log of initial concentration divided by final concentration. Now यहाँ पे आपको you have to pay attention to the fact that this is 10% completion. मतलब 90% of the reaction is still left. ठीक है, तो when we'll be talking about the final concentration, so that would be 90 over here. ठीक है, if you are assuming the initial concentration to be 100, जो फाइनल कंसंट्रेशन होगा दैट वुड बी 90 एंड नॉट 10. आपको यही फिगर उठा के रख नहीं देना है बस. ठीक है, यू अंडरस्टैंड व्हाट इज हैपनिंग. 10% इज कंप्लीटिंग एंड 90% इज रिमेनिंग. ठीक है, और हमें यहाँ पे रिमेनिंग अमाउंट लिखना होता है कि विच इज द व्हाट इज द फाइनल कंसंट्रेशन ऑफ द रिएक्टेंट विच इज लेफ्ट अनयूज्ड इन द रिएक्शन. इट इज नॉट यूटिलाइज्ड. ठीक है, तो 10% has already being utilized. So what is left is 90. So this would be okay, I'll write down. So at 298 Kelvin, what happens at 298 Kelvin? If you write down this equation, so this would be time 2.303 by k. आपको k की वैल्यू भी पता नहीं है इस इक्वेशन में, ठीक है? So this would be log. If you consider the initial to be 100, assume it to be 100 because it is given in percentage form and the final would be 90. ठीक है? Just remember this, 10% completion मतलब 100 minus 10. Similarly, 25% completion मतलब 100 minus 25. You have to put in over here in the integrated rate law. ठीक है? So when you solve this whole RHS value, so this would be 10 by 9. So log of 10 by 9 and you have 2.303 by k. So when you solve this, you will get 0.1054 upon k. अब k भी unknown है, तो obviously this will not be a constant value. This will be by k. Similarly, when you will do it for other temperature, which is 308 Kelvin, time would be 2.303 by k. Log again assumed to be 100 and this would be 100 minus 25. So 75. Okay? So this would be basically 4 by 3. Log of 4 by 3. So on doing the calculation, this will come out to be 2.2877 by k again. ठीक है? अच्छा, one thing more. Just to avoid confusion, what we will do is हम लोग यहाँ पे formulation change करेंगे because we know कि at a different temperature the value of k will be different. ठीक है? Obviously the value of k will be different at different temperatures. That is what is the difference over here. और जब value of k अलग होगा तो value of time भी अलग होगा. This time will be also different. तो हम लोग यहाँ पे क्या करेंगे? For first temperature के लिए हम यहाँ k1 ले लेंगे और यहाँ t1 ले लेंगे. ठीक है? To avoid any confusion, this will be k2. This will be k2 and this will be t2. This will be k1. ठीक है? क्योंकि अलग अलग data points है, that's why. So this will be k2. Okay, for two different points. Now according to the question says that both these time, जो time हमें कितना, ये हमने क्या calculate किया? हमने calculate किया time कितना लग रहा है according to this statement. Both these times they are equal. तो हमें करना क्या है? तो question says कि t1 is equals to t2. तो हमें simply इन expressions को equalize कर देना है. अब क्या करेंगे? When t1 is equals to time is equal, so this will be 0.1054 by k1. This will be by k2. ठीक है? तो इसका मतलब हमें k1 और k2 में रिलेशन पता चल गया. So according to this, what happens is this k2 by k1 would be 2.7296. ठीक है? तो ये कैलकुलेशन के बाद आया है. This is k2 by k1. So basically how are k2 and k1 related to each other? ये यहाँ से आया है. ठीक है? According to this question. Now you will save this equation. This is a very useful equation. Now as we know that from the Arrhenius equation, when we were doing the Arrhenius equation is for a particular relation between the temperature and that rate constant. ठीक है? Now हम लोगों ने we did it for two data points and then we subtracted those equations. ठीक है? And we also learned another form of the Arrhenius equation which can be useful when we have been given two data points. ठीक है? So because here also we have been given two temperatures and 2k, so that is why we will be using that different formulation. ठीक है? तो वो formulation क्या कहती है? वो formulation कहती है log of k2 minus k2 by k1 will be EA. You can go back to the derivation if you want. 2.303 R 1 upon T1 minus 1 upon T2. ठीक है, दिस इज व्हाट इज दैट द डिफरेंट फॉर्मुलेशन ऑफ द आरएनएस इक्वेशन इटसेल्फ. ठीक है, तो अब आप देखो ये जो हमने फ्रैक्शन निकाला है इस पार्ट से, वो फ्रैक्शन हम डायरेक्टली यहाँ पे यूज कर सकते हैं. तो इवन इफ वी हैव नॉट बीन गिवन the actual values of K2 and K1, we were successful in finding this fraction. ठीक है, relative value, और वही फ्रैक्शन हम यहाँ पे पुट कर देंगे. ठीक है, नाउ हमें टेम्परेचर भी पता है. हम क्या करेंगे, लॉग ऑफ यहाँ पे K2/K1 की जगह पे ये वैल्यू डालेंगे जो ऊपर हमने निकाला. एक्टिवेशन एनर्जी हमें नहीं पता, 2.303 into R is also known, 8.314, and temperature is also known. So initial temperature was 1/298 and final was T2 was 308 Kelvin. In Kelvin में ही temperature डालते हैं. ठीक है, तो in this whole complete equation you are able to see कि only this activation energy वाला जो activation energy is the unknown over here. ठीक है, तो you can very easily find out on calculation the value of activation energy, which will come out to be 76.64 किलो जूल. अब फिर से यहाँ पे यूनिट पे ध्यान दीजिए, इट्स किलो जूल. तो आपको जो वैल्यू मिलेगा दैट विल बी 76,000, अराउंड 76,640 अकॉर्डिंग टू दिस. ठीक है, तो यहाँ पे आई एम राइटिंग इट इन केजे पर मोल. So this is the activation energy first of all. ठीक है, तो क्वेश्चन में it was asked the activation energy. Now what they also asked in the question the value of K at some another temperature. So obviously now आपको पता चल चुका है, एक्टिवेशन एनर्जी भी पता है, और यू हैव बीन गिवन द कैपिटल वैल्यू ऑफ ए ऑल्सो, जो आरएनएस फैक्टर होता है. ठीक है, तो एट उन्होंने पूछा 318 केल्विन पे व्हाट इज द वैल्यू ऑफ के. ठीक है, तो एट द टेम्परेचर 318 केल्विन, ए तो हमारा कांस्टेंट ही रहेगा टेम्परेचर के साथ, दिस डजंट चेंज. ए इज दिस वैल्यू एंड यू हैव आल्सो फाउंड आउट द वैल्यू ऑफ एक्टिवेशन एनर्जी. ठीक है, तो आप सिंपली आरएनएस इक्वेशन यूज करिए and you will be able to find the value of K. K will be this value of A into exponential minus EA by RT. A is 4 into 10 to the power 10 into exponential. What was the activation energy? It was around 76640 in joules upon 8.314 into, और जो टेम्परेचर है वो हमें यही वाला रखना है, 318 केल्विन. ठीक है, this is a complete expression, everything is known, so you will be able to find the K, and K according to this calculation it comes out to be 1.034 into 10 to the power minus 2 per second. ठीक है, K is 1.034 into 10 to the power minus 2, and because it is first order reaction, so this is per second. This is the answer. So we have been able to find the activation energy and this K at a different temperature. Okay. So basically, I've tried to cover all the kinds of questions that I could. They are based on the rate laws or the concentration or the this activation energy and the Arrhenius equation thing, everything. So these will be all from my side. All kind of numericals have been discussed. So this will be the end of this lecture. All the best.